And here's another good question. So, we just want to draw our labels of our vectors. First up is the weight vector. The weight vector always points straight down. That arrow does not, but it's supposed to. But this vector is going to go straight down towards the center of the earth. We draw that as F, and we can label it as F sub G for weight. All right, normal force is always perpendicular. In this case, perpendicular to the surface. In this case, the normal force is going to be pointing straight up, because the surface is flat. Okay, so the normal force will look like this, and it should be the equal line, same length as the weight, because they are equal and opposite. The normal force can't be any greater than the weight, or it'd start levitating upward. Okay, the normal force cannot be any less than the weight, or it would fall through the surface. So it has to be the same length, equal and opposite, just like that. All right, force of friction. Well, if I say it's decelerating, that's good to know, but if I see the velocities going this direction, friction always points in the opposite direction. So friction has to be in the opposite direction of motion. So the force of friction will be there. All right? And then I ask about the net force. Well, two things to understand this answer. One, there's no other force acting on it. So the only force, these two are canceling out. So the only thing left is the force of friction. So that's one way for you to know that the net force is the same arrow. Okay, it's the force of friction. It's the same arrow. All right. Also, you see that it's decelerating. If it's decelerating, that means the arrow for the acceleration is going opposite the direction of the velocity. So it has to be going this way as well. So the net force is the same arrow as the force of friction. There you go.